When we talk about Vinova, we are talking about deep tech. We are late stage to the point that we are pre-exit, actually, in the sense that we are already in preliminary talks of potential M&A with the multi-trillion companies, so we have bankers tasked. It's a long adventure. We've been on it over 13 years. True story, it's actually a little bit fun. I don't know if it's a title of merit or not, but the first 2 seasons of HBO's Silicon Valley were in fact based in large part on Vinova. Happy to kind of provide fun details. But in reality, after 13 years, we are a relatively serious company, 1,500 patents. We were recently named second most innovative private company in the UK. And we have a lot of serious team members, so much more serious than what you see in the TV show for people that saw that TV show. So we have, as part of the founding team, the creator of the microprocessor, Rick, of course, as Julie mentioned, created what today we could call the first ever GPU. We also have, as investor and board advisor, former Secretary of State of the US, former co-head investment banking Europe of Goldman Sachs, etc., etc., and a pretty solid team. In particular, we are in a very, very good moment of our story with deep tech, and especially with foundational technologies like ours, and in a second we will say what we do. It takes a long time because it's very much like pharma in many ways, in the sense that it's not just important to have good technologies, but you need to validate them, you need to standardize them, get them adopted by the ecosystem, etc., and then you can scale them. And luckily, we passed all those stages, and we are now in the scale-up phase. And we got to this scale-up phase precisely when AI is ramping up essentially the value of what we do by 10x or more. So let's go to more specifically what we do. And in a way, we redesigned the way in which the digital data architecture is structured in a way that is very, very essential to AI and to data transfer. And this is actually the real middle out again for people that saw the TV show.
We're not going to go into a deep description of the technology because it probably would be too complex for most people to understand on there. But fundamentally, all of our technologies are based around the concept of hierarchy of information. So if you look at this picture, you can see this is a full resolution image. You can see there's an aeroplane there, but you can see with a much lower resolution that there's an aeroplane there. And in fact, most image information is the same at different resolutions. So why represent data at this level if you can represent it here and just scale it up? And so the basic concept on this is that it's some information you can infer from below and other information that you need to add. And so that's how this works from a conceptual point of view. And that creates for efficiency in terms of actually compression of that information. And that we've used, and we standardized this approach for imaging. That's called SMPTE VC6. And we also have a video-based standard. But this becomes really interesting when you start looking at the world of AI, and when you look at what you do with images and video, which is where the huge costs in AI are coming. If you think today where we are with sort of ChatGPT and text responses, it's like going back to the early 90s and SMS messaging versus the advent of Instagram and stuff like that. It's a massive, massive change, but we're only just starting to see that on there. But if you were doing AI processing on this, the way you would do it today with the traditional image formats is you would decode this, you would then downsample it to this, because then you only need to analyze this, and that saves your processing. However, you've had to fetch all this data, and most of the data is here, not here, decode, process it, shrink it, before you do that analysis. Now that is quicker than trying to do the analysis up here. But with VC6, you could just decode that, and therefore you fetch less data. But it's more than that, because within the VC6 format, you have what we call region of interest. And that means that you can identify, say, that is interesting, but you could get that level of quality by only decoding the region rather than the whole thing. And again, it's more the fetching of the data that actually is important for AI rather than the actual decoding of it on there.
Yeah, and this is an architectural thing. Of course, Rick made an example with an image or a video, but think about a CAT scan. If you need to look at the heart valve of your heart, and currently with today's technology and AI, or a person would have to get the entire CAT scan of the entire body, which is a huge file, and then decode all of it, which takes a long time, and then you focus on 0.1% of the information. With this data architecture, AI just needs to get 0.1% of the information, process 0.1% of the information, essentially you get orders of magnitude of speed up. And this is kind of the concept of turning monolithic files into something that behaves a little bit like an API. And it's a kind of natural way to organize information for the AI age. This was a concept 13 years ago, but today it was embedded in 3 data formats that are international standards and are taking up in different sectors. And they are pretty much everywhere. The nice thing is that what we call visual data, and again, it's images, it's video, it's radar, it's LiDAR, it's thermal sensor, is pretty much everywhere. It's in your pockets, in TVs, in cars, in data centers, in robots for sensor fusion, in drones, as we saw earlier, and we should talk about it because I'll show something that is very relevant to Spilin, I guess. And so, you know, it's really a vast ecosystem that moves loads of trillions of dollars. And our technology is also scaling up precisely in the moment in which AI is moving from text to vision. Essentially, if you heard recently Jensen or Demis Hassabis or Sam Altman or Elon Musk, they are talking a lot about the next phase of AI, which is physical AI, visual AI, essentially AI coming into the world with sensor data. And the processing requirements skyrocket, literally. So here we are talking, you know, Jensen last week communicated the revenue target for next year for NVIDIA, $1 trillion. You know, in 2023, there were like $27 billion. So, you know, this kind of project, this ramps, but it's a power limited industry. So it's really about how can we process all this data. And as Rick said, you know, it's not really a lot about processing when you move to visual data.
Yeah, it's always been about the bottleneck of getting information in. When we developed the SuperFX chip, well, the first GPU back in the late 80s, we started that. We designed it to cope with what was the physical speed of we could get information in and out. There was no point in being faster. We then went and developed other things, and about 30 years ago, when NVIDIA was a small little company, I remember having a meeting with Jensen in a room not much bigger than this, having a discussion, shall we say, about how they measured what was called polygon throughput on their devices, and he was saying, oh, it can do, I can't remember what the numbers were, but it was based on the number of single pixels that it could actually physically draw. But the way that their GPUs worked is you had to feed that information in, and that information was far larger than the actual pixels you were, and you couldn't do that. So I said, you've got to count it from the amount of data you can get in, not the amount that you could do if you had the data, because that doesn't work that way. And actually, today, when you look at what we're doing with AI, that problem is far worse than it was back then. But it hasn't changed. But actually, you've got far more data externally, and the more image-based stuff you do, the worse this gets. And that's if you follow the prices of electronics, you'll see they're going up massively at the moment because of 2 things: the cost of DRAM and the cost of the flash memory. And the reason those prices are skyrocketing is in order to try and move this, they're trying to move as much of this to here so it's closer, but it's still the bottleneck. So it doesn't take a rocket scientist to work out that if you could say, just if you said simply, you just halved the amount of data that had to come through here, that would double the throughput of that system. And if you can do better than that, you can do it. And the great thing about our formats is that they inherently do that. It's the way that they work. So they are ideal for working in this environment, but also we've made it so that they actually work natively on the GPU. So it's code that runs directly on the GPU. So we keep the bottleneck out and we deal with it there rather than dealing with it somewhere here, which then creates a new bottleneck itself. So it in our experiments and proof points we've done with NVIDIA, we've been talking about speed ups of like 5 to 10 times for doing analytics and training and things like that. Now, what do you do with that information? You do more stuff. You know, the AI today is limited literally by the electricity. That is the limiting factor, and that'll create all sorts of interesting things in terms of power generation. But it's going to be the limiting factor probably for decades to come. But the more you can do with the resource you've got, the more value you can generate, and the more cost effective that you can be, the better your service that you can be.
Yeah. And what we are talking about is really pretty big, because if you think about AI, everybody currently is seeing the need to make it better, because it's a multi-trillion industry in terms of investments in data centers, it's power limited, and everybody is looking at improvements in the compute infrastructure, so in the chips, in the data centers, or in the models, so like in the ChatGPT 6 versus Gemini, etc. What people had been missing before the Vinova effect was really that data, especially when you start moving from text and numbers to visual data, so to sensor data. Data structure and data architecture makes a big difference, and as Rick says, can make even more than a 10x difference with the same compute infrastructure and the same foundational models. And what's important is that we're not saying it ourselves. In 13 years, as I was saying, we've done a lot of validation, standardization, etc. So the information is actually coming from the tech titans. So there are a number of published papers with NVIDIA, with Intel, with Microsoft, with Meta, with McKinsey as well, and in general with 50 and more industry leaders that have been working with us to essentially empower the ecosystem with our technologies. And the results, as Rick was saying, are pretty stellar for AI. We're seeing in different applications, the benefits are very often also greater than 10 times. We got up to 25 times in certain cases, but also in very low latency situations, they are consistently over 5 times speed up, sometimes with 20 times reduction in data transfers. They're really massive numbers. And of course, imagine in an autonomous vehicle what it means to take the same decision in 5 times less time. It's the difference between life and death. Or taking in the same amount of time, a much better decision, because the AI had more time to think, because people think that it's only AI time, but you need to get the data to AI, and if you cut that, it's much better. Other than that, we also have...
so we have the traditional use case of video, and kind of where we started, if you like,
exactly.
Is in normal video, so video generation and things. But the way that our technologies work, they're actually simpler than the traditional technologies, which means it actually uses less computation to encode the videos and decode the videos and images. And that's an important thing in terms of sustainability and in terms of what you can do. But they also reduce the data rates of that information, typically between 20 and 40%, which again has a cost saving in that traditional space.
Yeah, this is why leading social media are adopting our technology, rolling it out for traditional video services, and also at
traditional TV
scale.
Yeah, traditional TV. So we've been working now for a number of years on a new TV standard in Brazil, which goes live next month. Last week, in the last 2 weeks, I've been in China, Taiwan, South Korea, and then at the very exciting DVB World in Amsterdam, talking to the TV manufacturers, the chip companies, the set-top box companies, in making sure this all rolls out. The first boxes ship next week from China to Brazil, ready for the rollout of this, but this is a mandated technology. So Brazil does something unusual in TV, where the government mandates it and puts penalties in place So the manufacturers, if they do not meet certain quotas that they sell, they have the taxes, basically tariffs, on doing that, which means it will happen, and it's doing. In fact, just today when I've been here, there's been another chip company has asked us for information to do it. So although we help the companies do it, they can do it themselves. It's an international standard. But we're now at this inflection point where it has a snowball effect and it's moving on by itself.
Yeah, and it's important because Brazil, of course, and this is mandatory revenues for the next 20 years. We get 40 to 70 cents per device. It also expands to the whole Latin America, but it's mostly important for the entire planet because the ecosystem of video is the same for the entire planet. And so, thanks to Brazil, it's essentially conquering also other regions. And then there are use cases like, Svilen probably, this is actually the relevant one for you because we've been working, in this case, it's public information with Leonardo on similar drones, like you were mentioning, the Falco or the Hero. And this comes from EU exercises where it shows like our technology was allowing a lower bitrate, a much better quality, and a lower latency all at once. By the way, with lower processing on the actual device.
And that didn't require any new hardware. That was using the existing hardware that was already in that aircraft.
Yeah.
It was just
in NVIDIA
software.
Jetson in that case.
Yeah.
All this is uniquely owned by Vinova. We have over 1,500 patents. In particular, our patents are not just mapping on our own formats. We also have patents on very popular international standards like HEVC, VVC, AV1. Actually, also patents on generative AI foundations. This is actually an interesting mapping that Tech and IP has done last month, where they mapped the patent portfolios for generative AI and actually mapping how recent, how many years of life the portfolio has, how relevant it is, and the size of the portfolio. Actually, Vinova came up on top. And as you can see, the other names are small companies like Amazon, Apple, Alphabet, Nokia, Qualcomm. So, we never heard of. Exactly. We have a pretty good patent moat, let's say. In terms of financials, it's a very nice inflection point. These things ramp up very far. We could show you the numbers, and of course, we're happy to do it. Probably you wouldn't believe them, so it's better to talk about the past and what happened to past standards. So, it's actually, this is stuff that is real. Then we can show you our projections. The previous two MPEG files collected H.264 that was priced very low, over $15 billion over the life of the standard. HEVC is probably going to exceed 25 and possibly 30 billions. It's monetizing about 1.5 billions per year right now and growing.
The key thing about these is that the patents are owned by hundreds of companies, including us.
Yep. For MPEG-5,
we own the whole lot.
Yeah.
So if we could do the same as that, if we do
even less
than that, we own all of it.
Yeah. And this is just one of the three. So, we are the reason why we are in a very relevant corporate action moment is that the AI story requires a corporate configuration in terms of go-to-market that is beyond what we can do. We are a 100-people company. So far, we were operating mostly in media and defense, but currently the AI story, which is the most recent because multimodal AI is happening now, requires us to work in robotics, in medical imaging, in space, in automotive, in a number of sectors where we are not equipped with go-to-market, and so we need to do it with the big shoulder of a big strategic partner like a multi-trillion company or a multi-100-billion company in AI. And that's why we initiated the process, precisely because there are serious discussions. What we are raising now is a 20 million plus mezzanine round to strengthen our balance sheet and make sure that in these negotiations we present ourselves with a strong spine and the best bargaining position. So currently, if people are interested, of course, we are open in terms of mezzanine on several configurations. We have various options for smaller tickets. It's also possible to do a safe with discount. Yeah, we're very happy if anybody wants to take part in this part of the journey. It's an exciting time.